Myself, Kartik. So here I am going to give a seminar on Boyce code normal form. Boyce code normal form, in short, it is also called as BCNF. It is an advanced version of 3NF. To understand BCNF, first we want to know a little about 2NF and 3NF. What is 2NF? So the 2NF means the relation should not contain any partial dependencies and a non-key attribute which depends on a part of partial key is called partial dependency. So and in what is 3NF? So 3NF, the relation should not contain any transitive dependency. A dependency between non-key attribute is called transitive dependency.
BCNF means it is slightly strong versions of 3NF if a relation R is in BCNF if and only for every one of its dependencies are in the form of x tends to y. At least one of the following conditions are held. First one, x tends to y is a trivial functional dependency. Trivial means dependencies of an attribute on a set of attributes. Second one, X is a super key for schema R. Super key means combinations of columns that uniquely identify any row within a relation table. Let us consider an example, student enrollment table. Here you can see the values of student ID, course and teacher. Here student ID and course are primary keys. Why means a student can enroll any number of courses as well as a course can contain any number of students. That is, we can see many to many relation here. Another attribute is teacher, that is a non-key attribute. So here with this relation we are the some key issues. We can see the key issues are: first one, a subject can have multiple teachers. Issue number 2, for a single subject there may be multiple students have got enrolled. We can go for DBMS. See ID number 101, 102 and 104. 3 students are registered DBMS subject. Issue number 3, a teacher can teach only one core subject. Example, if you go for teacher called Mr. A, he or she teaches only a DBMS subject. Then issue number 4, for a single course a student can take a help from a single teacher. So here you can see that 101 for rule number 101 for the subject DBMS, that is no other two teachers to teach DBMS for that student. The last issue is issue number 5. For a single course we can have multiple number of teachers. See, DBMS have two teachers, Mr. A and Mr. C. Keeping all the issues, 5 issues, we are having two functional dependency in the relation. First one, student ID course determines teacher, because I told you that a standard for a single subject, student for a single subject can take guidance from a single teacher. The second functional dependency is teacher determines course, because a single teacher can give guidance to a single subject only. So here student ID and course are prime attributes. So this relation is in 1NF because there is no non-atomic data. We are not finding any partial dependencies. So the relation is in 2NF. Now student ID course determines teacher. I am not finding teacher determines any other non-key attribute. So there is no transitive dependency. So this relation also is in 3NF. This is in 3NF, but still we are having anomalies like we can't do any insertion, deletion operations like that because teacher determines course. A teacher is a non-key attribute and course is a key attribute. Non-key attribute determines key attribute course. If this type of dependencies arise, it should be removed. The relation is not in BCNF. If we have to determine that must be a super key, but teacher is not a super key, we can so the relation we can split into two parts: table A and table B. Table A contains student ID teacher, and then table B contains teacher course. In table A, teacher ID is a foreign key. Teacher ID reference IDs from table B. In table B, teacher ID attribute is a super key. It determines teacher name and course he or she teaches. Last final equation is teacher ID teacher comma courses. There is no partial dependency and transitive dependencies. So the relation is in BCNF. Thank you.